Howdy, trigonometry friends. Today we're going to go over chapter 2.2 in the book, basically rotations and trigonometric functions. So rotations, we all kind of have a basic general intuitive understanding of rotation. Definition here of rotation is essentially the same. Rotation, simply we begin at a reference line, usually going in that direction, and then we measure up how far a second line is rotated from that angle. That's what a rotation is. Pretty basic. Trigonometric functions, also called circular functions. Basically, they're called circular functions because they can be thought of as functions of the unit circle. We also have can use them to describe the ratio of the legs of a right triangle, and we're going to start off with that approach right here, right now. So many of you are probably already familiar with these relationships. Some of you may not be, so we're going to touch base on this. What this is saying is that we've got sine theta. So what is theta? Theta is the measure of the angle right there, right? That is our theta right there. And so you can see sine, cosine, and tan, they're all functions of that rotation. Alright, so now what is the adjacent? Well, the adjacent is just the leg of the triangle that is adjacent to that angle that we're looking at. So we have adjacent right here, and note that it comes into play for the cosine and then also in the tangent function. Alright, now what do we mean by the opposite? The opposite is just the opposite of that angle. And so we have the opposite coming for the sine, and then also for the tangent right here. Hypotenuse, it's the only one that's left. The hypotenuse is always the angle that is opposite of the right angle. And just for clarity, this would be the right angle. A right angle is an angle of 90 degrees or pi over 2. And you can note how it just goes, perfectly perpendicular to each other. Alright, so let's go into this a little bit more. First off, let's color code this further. Hypotenuse and hypotenuse here. Alright, so sine is just a function, once again, of the opposite leg over the hypotenuse. Cosine, it's the adjacent over the hypotenuse. While tangent is a ratio of the opposite and adjacent. So the sine, cosine, tan functions are simply the ratio of different legs of the triangle. And we can remember this relationship more easily with this an acronym right here, SOHCAHTOA. So, sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. And TOA, tangent is opposite over adjacent. SOHCAHTOA. These are the three main trig functions. We will be touching base on some others, but these are the three big ones that you need to have burned into your memory. Okay, so theta is a measure of the rotation. Right, we talked about it just a moment ago. It measures what your rotation is from some reference line. An angle describes how far a line is rotated. So, in degrees, we say something is fully rotated, going, starting from here, and you go all the way around. That's one full rotation. That is 360 degrees. I'm sure everyone has heard 360 degrees before, and most of you guys have probably heard something about radians. If not, we're starting from the beginning, so don't worry if you've never heard the term before. But radians for one full rotation is 2 pi. And note how this goes along with what we were talking about in our earlier discussion with the terminal length, right? Terminal length all the way around is 2 pi. One full rotation in radians is 2 pi. Alright, so as we stated before, angles in a circle are measured from a reference line. So a quick note on arc length and as it relates to the radians. We talked about terminal length before. Terminal length and arc length are really just the same thing. When we talk about arc length, we usually say S equals R theta. Like so. And so that would be how we would calculate the arc length. Theta is given in radians, not degrees. And so basically, if you have this set up here, this is theta. Note this is not a right triangle. Let me draw that curve a little bit more clearly there. There we go. So this is part of a circle. As imagine I got that at the center. And so the arc length would be from there to there. That's how we would define our arc length. And then the radius would be here and here, of course. Now, 1 radian is defined when we've got the arc length is the same as the radius. So on the unit circle, or for any circle for that matter. So we got the radius and the radius, then we have our arc length right here, and we've got it equal to the radius. And here's theta. So we want to find the radians for this one, or find the angle. So we've got, again, S equals R theta. The arc length is the same as the radius. Radius is still the radius times theta. Radiuses cancel each other by dividing the radius on both sides, and we're left with theta equaling 1. And I prefer writing it like that. That's a little more proper if you're typing a computer. This is going to read better if you put the variable on the left-hand side. But so that's how 1 radian is defined. Okay. All right, so that's just a quick aside on radians. We're going to be talking a lot more about those moving forward. Right now, I want to move on to this picture right here. Note this is a unit circle, and we are centered at the origin, right? That's how it's defined. So let's just draw a random ray from the origin, or out to here, or should I say line segment. And we're going to go ahead and bring it down. Hey, look at that. We've got a triangle, or right triangle, popping up right here. This is the unit circle again. So the radius is 1. Okay, so note we've got our angle, our rotation right here at theta. And so right here, this would be our x coordinate, and note from up here, this is our y coordinate. So the length or the height of that triangle is y naught, and the length of the triangle is x naught. Let's apply what we know from before, cosine of the angle, cosine theta, equals the adjacent divided by the hypotenuse. X naught over 1, well, that's just x naught. So note the x and y coordinates that we have here. Well, x naught is the same as cosine theta. Okay, so that's pretty nice. What about sine theta? Well, sine theta is the opposite over the hypotenuse. That would be y naught divided by 1, which is just y naught. So that tells us that sine theta is the same as the y coordinate on the unit circle. Alright, so that's cosine and sine. Let's look at some other trigonometric functions. What about tan theta? Well, tan theta is the opposite over adjacent, the TOA part of SOHCAHTOA. And so tan theta, well, that's going to be the y coordinate divided by the x coordinate, right? Opposite over adjacent again, which is the same thing as sine theta over cosine theta. All right, so these three are very important to keep in mind. We're going to start expanding our list of trigonometric functions right now and I'll introduce the secant theta, which we define as 1 divided by the cosine theta. Which, again, is the same thing as 1 divided by the x coordinate on the unit circle. If you wanted to be even more general, it would be the radius divided by the x coordinate, but of course the radius simply equals 1. Alright, so the cosecant theta equals 1 divided by sine theta, which is 1 over the y coordinate, which more generally would be the radius divided by the y coordinate, but again, a radius is 1. So that's secant and cosecant. One more co-function on here, you might have guessed, is going to be the cotangent. And so cotangent of theta equals 1 divided by tan theta. And we have a couple of different ways to express this one. Since tangent is sine over cosine, well then obviously cotangent of theta must be cosine theta over sine theta, right? Just the exact opposite of what tangent theta was, or the reciprocal, if you will. And this would have, as far as coordinates on the unit circle, would have our x naught over y naught. Okay, and so there we have it. Those are the most basic trig functions. I want us real fast to look at the Pythagorean identity on here. Remember, that is a squared plus b squared equals c squared. Alright, so keep in mind A and B are both the legs of the right triangle, and C is the hypotenuse of the right triangle. So looking at the right triangle, well, what the legs are respectively x naught squared and y naught squared. And then the hypotenuse is simply 1. So 1 squared is just 1, so we'll just write 1. We know the x naught and y naught, well, those are the same thing as cosine and sine. So we have here cosine theta squared plus sine theta squared equals 1. And note that when we're squaring the trig functions, how I place the square right there. That's just kind of a normally accepted nomenclature. The reason for that is so that you don't think that you're squaring the theta as opposed to the whole thing. That's why it's placed right there. So cosine squared theta plus sine squared theta, know it, love it, live by it. It's not going away. It's very important for this class and for classes that you go beyond this. Now the Pythagorean identity for trig functions has several different forms. This is the main form right here. But it also takes on a couple different forms with the co-functions. So if we want to get this guy here in terms of one of the co-functions, we have to divide by the different trig functions. So let's go ahead and start off by dividing by cosine squared theta, right? We're dividing each term by cosine squared. And so when we do that, the first term becomes 1, because cosine squared divided by cosine squared is 1. And the next term is sine squared divided by cosine squared. And so sine over cosine is the same thing as tangent, so this becomes tangent squared theta. And then equals 1 divided by cosine squared. So 1 over cosine squared, and look over here, is going to be secant squared. Okay. And so that's the other important one to keep in mind. Now let's go ahead and divide this original equation here now by sine squared. And when we do this, cosine squared divided by sine squared, well, that's cotangent squared. And then, of course, sine squared divided by sine squared is 1. And then we have 1 divided by sine squared theta, which is equals cosecant squared. Okay. So I will see you guys, make sure you watch the next video that will be posted right underneath this on the back of this handout.